Good morning. So we are looking at piecewise functions. A piecewise function is a function that's defined by two or more equations, and each equation applies to a different part of the domain. So for example, this equation, 2x plus 1, only applies to the function if x is greater than less than or equal to 0. So where is x less than or equal to 0? Well, x equals 0 along the y-axis, right? So this part of the graph is where x is less than or equal to 0. We're breaking up the domain, which is all of the x values, into different chunks with vertical lines, right? So if x is less than or equal to 0 applies to this side of the graph. So this line is 2x plus 1. And x plus 3 only exists when x is greater than 0. So if I cover this half of the graph, this is where x is greater than 0. X is 1, 2, 3, etc. Right? So this line is x plus 3. And you'll notice that there is a closed circle, a filled in dot, for the first equation, 2x plus 1 is if x is less than or equal to 0, and that's because of this or equal to symbol. So when it is less than or equal to, greater than or equal to, you will have a filled in dot at the endpoint. When it is less than or greater than, you will have an open dot on the endpoint. This includes that x value. This excludes that x value, right? So when you're evaluating, for example, in this set, we have f of x is equal to 4x minus 1 if x is less than 3, and x plus 7 if x is greater than or equal to 3. So I'm going to do these first two, and then you are going to do the rest of this. So f of 5, I first need to figure out if this value is part of this domain or this domain. F of 5, let's see, 5 is certainly greater than 3, which means that I'm going to use this second equation, x plus 7, because of this statement. 5 is greater than 3, so I use this x plus 7. So I'm going to use x plus 7 for this one. So f of 5 is going to be 5 plus 7. Remember, we're plugging in the x value into our variable here, so this will be 12. F of negative 9, however, negative 9 is less than 3, so I'm looking at these statements to determine which of the equations I'm going to use. Negative 9 is less than 3, so I'm going to use my 4x minus 1 statement. So this is going to be 4 times negative 9 minus 1. 4 times negative 9 is negative 36. Negative 36 minus 1 is negative 37. Right. I would like you to do these on your own. So if you have not done these yet, go ahead and pause the video, work through these, and when you are done, check your answers in the binder on the podium. Thank you. The answers will be here for you. After you have done some evaluating of piecewise functions, we're going to graph them. So we're going to remind ourselves how we graph linear equations. Generally, linear equations are in slope-intercept form, right? mx plus b, y equals mx plus b, where m is the slope, and b is the y-intercept. And I'm actually going to switch to a pencil for this, and I'll show you why in a moment here. So I have two equations with different domains. One of them is where x is less than or equal to 0, so that's going to be this half of the graph. The other one is going to be x is greater than 0, that's going to be this half of the graph. And keep in mind, sometimes it's not 0, sometimes it's going to be x is less than or equal to 3, and x is greater than 3 or something, right? But we're separating our graph with vertical lines. So this particular vertical line is at x equals 0. To the left of this line will be this line, and to the right of this line will be this one. Okay. So the reason I'm switching to a pencil here is so that I can graph the whole line and then erase the part that doesn't apply. So let's graph negative 3x plus 2 first. 2 is our y-intercept, so I'm going to put a point at 2. And then negative 3 is our slope, so I'm going to go down 3 and to the right 1, down 3 to the right 1, etc. And then I'm going to draw that line. I'm just going to kind of sketch it in really gently here because I know I'm going to erase some of it. There's that first line, negative 3x plus 2. Now I have to figure out, okay, it's only valid when x is less than or equal to 0. So that means everything above x equals 0 is going to go away. Now I can go back with my pen, if you use a pen, and draw in that section of the line. And because we have this or equal to bar in our inequality symbol, I'm going to include with a filled in circle that endpoint. So there's that first line, negative 3x plus 2, but only when x is less than or equal to 0. There it is. Now let's do the next one. Negative x minus 3, well, I've got a y-intercept down at negative 3. Negative x means my slope is negative 1, so I'm going to go down 1 and over 1, down 1 and over 1, and I'm going to fill in the rest of the line. Give or take like this. And I am only graphing that line if x is greater than 0, so I know I'm going to be erasing everything where x is less than 0. So now I have the section of the line I need. I can fill it in pen, and because there is no greater than or equal to symbol here, I'm going to have an open circle at my endpoint. Now, the domain and range. The domain, again, is all of the x values that you are allowed to plug into this equation. And in this case, I'm scanning from left to right. Are there any x values that are not on this green line here? Well, I know that this arrow goes off to infinity to the left, and this arrow goes off to infinity to the right. I've got an x equals all the way up to 0, and then all the way up to infinity. So my domain is all real numbers. And you can say this r, which means all real numbers. You could also put it in interval notation, which looks like this, negative infinity to infinity. Either one of those would be fine. Our range, however, is not all real numbers. So now I'm scanning bottom up, right? I'm looking at all of the y values that come out of this function. And certainly this arrow goes down to negative infinity, but it stops at negative 3. I don't have any y values on this line in between negative 3 and 2. Good morning. So I'm going to say this goes from negative infinity to negative 3, and I want to exclude this endpoint. It's an open circle, right? So it does not count. So I'm going to use a parentheses, which means it does not include that negative 3. Then I have my union symbol, and then it starts up again at 2, and I'm going to use a bracket to say that that is inclusive of the endpoint, and it goes from 2 to infinity. So domain, range. Range is not all real numbers because we have to exclude all of these things. Now, if interval notation is not your thing, you could also say y is less than negative 3 and y is greater than or equal to 2. That would also work as well. One of those. All right, so I would like you to take a look at these examples, 10, 11, 12, and 13, and see if you can graph some of these on your own. So this first one separates the graph at 0. So again, that y-axis is going to be the separation between the two lines. This one, however, separates at negative 2. So you're going to have one line that is to the left of negative 2 and another line that's to the right of -2. Right? We're looking at these statements to determine which part of the graph includes those lines. So, go ahead and give it a shot. And also check your work when you come back.